Have you ever had something unexpected and catastrophic happen to a piece of tech you owned? Maybe you dropped your cell phone and it shattered, or spilled a glass of water all over your laptop. I know it's happened to me, and no, it's not fun. While hardware may be hard to replace, data can be even harder to get back, especially lost photos of special moments, important documents, or more. In this module, we're going to arm you with tools you need to be prepared for these accidents, so you can minimize the impact and loss of data. Alright, let's get right into it. Data recovery. What exactly is data recovery? If you've ever broken a cell phone, you probably lost some good pictures along with the phone itself. Data recovery is a process of attempting to recover the data that's lost from the broken phone. But this is just one example of attempting to recover from unexpected data loss. Data recovery, in general terms, is the process of trying to restore data after an unexpected event that results in data loss or corruption. Maybe a device that contains data was physically damaged, or an attacker performed malicious actions, or malware deleted critical data. Whatever the cause, the effect is the same. You've suddenly lost some really important data and you need to figure how to get it back. How you go about trying to restore this lost data depends on a few factors. One is the nature of the data loss. If a device has been damaged, you might be able to recover data from the damaged hardware. This could involve using data recovery software, which can analyze failed hard disks or flash drives and try to locate and extract data files. Another factor that would affect your data recovery is the presence of backups. If you're lucky, or you had the foresight to plan for the unexpected, you have data backed up, and you can restore the data that was lost. Data recovery is an important part of an IT system or organization. Since data is a critical component of any business operations, as an IT support specialist, part of your role is to ensure that this data is available and protected from corruption or loss. So, if something goes wrong, the organization can continue with their business operations with minimal disruptions. That's why it's critical to be able to recover from unexpected events that could impact your business data. When an unexpected event occurs, your main objective is to resume normal operations as soon as possible, while minimizing the disruption to business functions. By the end of this module, you will have practical tools and methods that you can use to protect your data. One of the most important techniques you will learn is how to effectively back up your data. The best way to be prepared for a data loss event is to have a well thought out disaster plan and procedure in place. Disaster plans should involve making regular backups of any and all critical data that's necessary for your ongoing business processes. This includes things like customer data, system databases, system configs, and financial data. You'll learn more about how to design and implement a data disaster plan throughout this module. And lastly, you'll learn more about what IT folks call a postmortem. Imagine that something did go wrong with your systems and you had to use a disaster plan. You might have discovered issues when recovering your data that wasn't covered in the disaster plan. A postmortem is a way for you to document any problems you discovered along the way, and most importantly, the ways you fix them so you can make sure they don't happen again. Being unprepared for a major data loss event can and has severely impacted businesses. In the upcoming lessons, you'll learn how to prepare for data loss, which is a key part of any IT role. If you're interested in hearing more about how real companies have been impacted by unexpected data loss, check out the supplementary reading. Otherwise, we're going to kickstart our journey of data recovery with learning how to back up data. Ready? Let's get started. So you want to protect your organization from critical data loss. Good instincts. But where do you start? Let's run down some of the key things to keep in mind when designing a data backup and recovery plan. The first thing to figure out is what data you need to back up. In a perfect world, you should only be backing up data that's absolutely necessary for operations and can't be found in another source. So things like emails, sales databases, financial spreadsheets, server configurations, and databases should all be included. But what about the downloads directory on your laptop? Is it really necessary to back up all those cat pictures too? Probably not. Backing up data isn't free, Every additional file you back up takes up a little more disk space, increasing the overall costs of your backup solution. Once you've figured out what data you like to back up, you should find out how much total data you currently have. But it's not enough just to think about what your backup storage requirements are right now. Your organization may continue to grow and your backup should grow with it. Make sure that you account for future growth and choose a solution that's flexible enough to easily accommodate increases in data backups. Data can be backed up either locally to systems on-site, or the backup data can be sent off-site to remote systems. Both approaches have positives and negatives and can help reduce different risks. The advantage of on-site backup solutions is that the data is physically very close. This makes accessing the data a lot quicker. You won't need as much outbound bandwidth since you aren't sending the data out of your internal network. If you need to restore data from backups, that should happen pretty quickly since the data is close at hand. But what if the unexpected event is a building fire? Now the systems we were backing up along with the backup server have been lost in the fire. Yikes. We've lost everything. This is why off-site backups are strongly recommended. This involves making backups of critical data, then sending the backed up data off-site to remote systems in a different physical location. This could be another backup server that you control in a different office or a cloud-hosted backup service. But there are trade-offs. Yeah, off-site backups better prepare us for catastrophic events that can wipe out data from an entire office. But sending data off-site means that you need to transmit the data outside of your network. This means you need to consider things like encryption and bandwidth. Your internet connection will be used to transmit the backup data. Depending on how much data you're sending offsite and how fast the internet connection is, this could take a lot of time. Another important thing to consider is encryption of backups. Since backups will often contain sensitive and confidential business data, it's important the data is handled securely and stored in a way that prevents unauthorized access. When sending data offsite, it's especially important to make sure that data is being transmitted securely, preferably encrypted via TLS. But that's not all. The resulting backup data that's stored should also be encrypted at rest. This is just good security practice. In the next video, we'll discuss some of the practical tools that you can use to back up your data. So you're looking to bring a backup solution into your organization, but how do you choose between a DIY backup system or one of the many cloud providers? Well, let's start by looking at the trade-offs between the two. On-site or self-managed backups could be as simple as buying a commercial NAS device, loading it with a bunch of hard drives and sending data to it over the network. This would definitely work, but it might not be the best long-term solution. How do you grow the disk capacity when you need more storage space? How do you handle a failed hard disk? Because hard disks will fail eventually. By the way, it's important to call out these options aren't mutually exclusive. There's nothing stopping you from implementing both on-site and off-site backups. Actually, it's often recommended to have both if it's within your organization's budget. One more thing that you should consider when evaluating the backup strategy for an organization is backup time period. How long do you need to hang on to backups for? This answer will impact your long-term storage needs and overall cost to maintain a backup system. One approach, which balances cost with convenience, is to archive older data using a slower but cheaper storage mechanism. The standard medium for archival backup data storage is data tapes. These are a lot like audio cassette tapes since they use spools of magnetic tape run through machines that allow data to be written to and read back from the tape. Tape storage is pretty cheap, but isn't as easy or quick to access as data stored on hard drives or solid-state drives. This storage system is usually used for long-term archival purposes where data isn't likely to be needed. If it is needed, some delay in getting the data isn't a concern. There are dozens and dozens of backup solutions available. We won't cover specific ones since there are way too many, but we'll cover some common tools and give you some examples of backup solutions available. One is the command line utility rsync. Rsync isn't explicitly a backup tool, but it's very commonly used as one. It's a file transfer utility that's designed to efficiently transfer and synchronize files between locations or computers. Rsync supports compression and can use SSH to securely transfer data over a network. Using SSH It can also synchronize files between remote machines, making it super useful for simple automated backups. Apple has a first-party backup solution available for their Mac operating systems called Time Machine. It operates using an incremental backup model. Time Machine supports restoring an entire system from backup, or individual files. It even allows restoring older versions of backed up files. Microsoft also offers a first-party solution called Backup and Restore. This has two modes of operation. There's a file-based version where files are backed up to a zip archive, or there's the system image where the entire disk is saved block by block to a file. File-based backups support either complete backups or incremental ones. System image backups support differential mode, only backing up blocks on the disk that have changed since the last backup. If you want to learn more about these tools, follow the links in the supplemental readings after this lesson.
Sometimes people think that because it's an IT job, all they are looking for is technical knowledge or technical skills. So as a restaurant manager, I learned a lot of soft skills that helped me as an IT consultant. Just the empathy and the look on things, the creativity, punctuality, and really good customer service. You should put all that in your resume because those soft skills can make a difference.
There's one last super important topic when it comes to backups: testing them. The field of IT is littered with tragic tales of IT support specialists and sysadmins attempting to restore data from a backup after a data loss incident, only to discover that their backups are invalid. That's not just embarrassing, it's completely terrifying. The takeaway here is that it isn't sufficient to just set up regular backups. There's only half of the equation. The other half is a recovery process, and that process needs to be tested regularly. Restoration procedures should be documented and accessible so that anyone with the right access can restore operations when needed. You don't want your time off to be interrupted because your colleague back at the office doesn't know how to restore the SQL database from the backup, right? Of course not. So document the procedure and make sure you regularly test the documentation to make sure it works now and in the future. This process is called disaster recovery testing and is critical to ensuring a well-functioning recovery system. Disaster recovery testing should be a regular exercise that happens once a year or so. It should have different teams, including IT support specialists, going through simulations of disaster events. They'll test and evaluate how well prepared or unprepared your organization is for lots of unexpected events. These scenarios can be anything from a simulated natural disaster like an earthquake to a fictional event like a horde of zombies shutting down an office. If that's the case, backups would be the least of your worries, but it's still important. Whatever the scenario, it'll help your IT teams test their emergency procedures and figure out what works and, most importantly, what doesn't. These simulated events are the perfect way to discover any gaps in your planning. If you discover that you aren't protected from data loss in any given scenario, it's an opportunity to learn and fix this gap without risking real data loss. Sounds like a win-win, doesn't it? So we've talked about how important backups are and why you should be backing up any important data and some tools that can use to help you back up data. But how exactly do you decide when and how to back up data? Well, let's explore those options. There's a couple of ways to perform regular backups on data that's constantly changing. You can do a full backup on a regular basis, which involves making a copy of the data to be fully backed up. The full unmodified contents of all files to be backed up is included in this backup mechanism, whether the data was modified or not. In the case of data that doesn't change very often, like operating system configuration files, this approach can be inefficient. You're backing up multiple copies of data that isn't changing, which wastes space and uses bandwidth unnecessarily. That doesn't seem like the best idea, does it? A more efficient approach is to only back up files that have changed or been created since the last full backup. This is called a differential backup. The advantage is that you aren't storing backups of duplicated, unchanging data. Only the files that changed are backed up, saving us some storage space and time to perform the backup. but you wouldn't want to completely stop taking full backups. Over time, you'll wind up tracking and storing lots of copies of files that change a lot, which will also take up more and more disk space over time. To avoid this, it's a good practice to perform infrequent full backups while also doing more frequent differential backups. How often you perform a full backup will depend on how far back you want changes to be tracked. Let's say we perform full backups once every week and differential backups daily. In the worst case scenario, we'll lose close to 24 hours of data changes. That's not bad. Another efficient way to back up changing data is to perform regular incremental backups. While a differential backup backs files that have been changed or created, an incremental backup is when only the data that's changed in files is backed up. This is even more efficient in terms of both disk space and time required compared to differential backups. Again, you'll want to use frequent incremental backups along with less frequent full backups. But because this approach only stores differences in the files that have changed since the last incremental backup, it's possible that all incremental backups are needed to fully reconstruct the files. If one of these incremental backups is missing or corrupt, it might not be possible to recover data any more recently than the last full backup. Another drawback is that recovery might be more time consuming. This is because the most recent version of backed up data has to be recreated by integrating the last full backup with each incremental backup that follows. For super large files that are changing frequently, this could require a lot of time to process. One more thing backup systems can do to help save space is file compression. When creating a backup, all the files and folder structures will be copied and put into an archive. Archives are useful for keeping files organized and preserving folder structure. Besides archiving the files, backups can also be compressed. This is a mechanism of storing the same data while requiring less disk space by using complex algorithms. Those are way too complicated to go into detail here, but it's important to call out that not all data types lend themselves to being compressed. This means that space savings from compression will depend on what you're backing up. Another thing you should know about compressing backups is the expense of restoration. To recover data from a backup, it needs to be decompressed first. Depending on the size of your backups, this could take a lot of time and disk space to expand. We touched on backup storage location a bit in the last lesson, but let's dive into a little more detail. Good news, there's a pretty cheap and easy to maintain option out there for storing backup data on site. You can use a commercial NAS device or configure a file server with a large amount of disk space. Wherever you choose to store your backup data, you'll need a lot of space. You could go out and buy a giant 10 terabyte hard disk, which could work for a little while, but what do you do once your backup data grows to fill that one disk? Are they even making disks larger than 10 terabytes yet? Another thing to worry about is what you do if that one disk holding all your backed up data fails. Yikes, that wouldn't be good. These are issues a RAID array can address. RAID stands for Redundant Array of Independent Disks. It's a method of taking multiple physical disks and combining them into one large virtual disk. There are lots of types of RAID configuration called levels. Depending on the characteristics desired from the array, various RAID levels prioritize features like performance, capacity, or reliability. RAID arrays are a great, inexpensive way of creating a lot of data capacity while minimizing risk of data loss in the event of disk failure. They can even be flexible enough to allow future growth in disk capacity. We won't go into the nitty-gritty details of the different RAID levels available, but if you want to learn more, check out the supplemental readings at the end of this lesson. I want to stress the fact that RAID isn't a backup solution, it's a data storage solution that has some hardware failure redundancy available in some of the RAID levels. But storing data on a RAID array doesn't protect against accidentally deleting files or malware corrupting your data. This is so important that I'm going to say it one more time. RAID is not a replacement for backups. As an IT support specialist working closely with users in your organization, the topic of user backups is sure to come up. We've already covered backing up mission-critical operational data, but what about the spreadsheets and PDFs on Carly's laptop? She's going to want to make sure that she doesn't lose those if her laptop gets stolen. While it's important to have a backup solution for infrastructure and critical systems, you also have to think about your users and their valuable files. Ensuring reliable backups for client devices is a bit more challenging than infrastructure devices. There are likely to be lots of more client devices to back up compared to infrastructure ones. Plus, there are laptops, phones, and tablets that won't be in the office all the time. One solution to user backups is to use a cloud service designed for syncing and backing up files across platforms and devices. Some examples of these are things like Dropbox, Apple iCloud, and Google Drive, which are simple and straightforward to use. There's no complicated scheduling or configuration compared to infrastructure backups. They make it easy for users to configure what files or folders they want to have backed up and then ensure the files are synchronized with what's stored in the cloud. As an IT support specialist, this is especially relevant. When users accidentally spill a cup of coffee on their laptop, they're going to come to you hoping their precious family photos can be saved. Getting users set up with an easy-to-use and effective backup system for their files is a great way to avoid this situation.